All right, this is tape number 2 of chapter 1, and also will be the summary. The hybrid ring is usually primarily high-powered radio communication systems that perform two functions. During the transmitting period, the hybrid ring coupled the microwave energy with the transmitter of the antenna to allow no energy to reach the receiver. Okay. During the receive cycle, the hybrid ring completes couple the energy with the antenna receiver to allow no energy to reach the transmitter. Any device performs both of these types of functions is called a duplexer. A duplexer permits the system to use such an antenna both transmitting and receiving, so the only common application of the hybrid ring is a duplexer. The detail of the hybrid ring operation will be explained later in Neets module concerning duplexers. Or your ferrite devices. Ferrite devices come up with a material thickness that cover the useful magnetic properties at the same time high resistance for the current flow of the material. Primary material that is constructed from the ferrite is normally the common iron oxide. The impurity of the other oxides added. The compound of the iron oxide retains the property of the harmonic magnetic atoms. The impurity of the other oxides increase the resistance for the current flow of the combination property not found in conventional magnetic materials. Iron, for example, the good magnetic property is relatively low resistance. The general flow of the low resistance cover the eddy current, significant power loss of the high frequency. You want to review the Neets Module 2, Introduction, Alternating Current Transformers, Chapter 5. Ferrites, on the other hand, have sufficient resistance to be classified as semiconductors. The compound used for the composition of ferrites can be compared with the more favorable compounds used for the transistor construction. Transistor wide range of the magnetic electrical property of the produce the proper choice of atoms, right proportions. An example of the ferrite device figure 172, the steady magnetic field ferrite. Ferrites have long been used for the conventional frequency of the computer, television, magnetic recording device. These ferrites of microwave frequency, relatively new development, has considerable influence to design microwave systems. The impact of the microwave equipment was conformed to frequency of the system. The design possibilities were limited. The unique property of the ferrite provided the variable resistance of the microwave energy be manipulated to conform the microwave system. At present, ferrites use the load isolated with the shifted variable actuators, modulator switches in microwave systems. Operating ferrites, isolators, actuators, phase shift that will be explained in the following paragraph. The operating ferrites and the application will be explained later in the Neets module. Ferromagnetism is a continuation of the eventual domain theory of the magnetism that was explained in the Neets module 1. Matter energy direct current. The review of the section of magnetism might be helpful to you at this point. The magnetic property of any material result of the electronic movement with the material electron two base at the top of the motion of the orbital movement of the electron of the nucleus atom. Less familiar with the even more important of the movement of the electron in its own axis electron spin. Alright, you will recall the magnetic field that are generated by the current sense the current of the movement of the electrons, the movement of the electrons with the atomic rate of the magnetic field. The magnetic fields of the cover of the movement of the electrons about with the nucleus a little field with the magnetic property of the material. The magnetic field cover of the electron spin. Combined to give the material magnetic property different type of electron movements are in 137. Most of the material spin active the electrons randomly arranged with the magnetic field with the largely contact cancel out the material display with no significant magnetic property. The electron spin active within some of the materials such as the iron, nickel can be covered by applying external magnetic field of the alignment of the electrons will materially cover the magnetic field of the atom. The material then the magnet has properties. Electric spin axis nucleus for the atom orbital movement. In the absence of the external source of the force, the axis of any of the spinning objects tends to remain pointed only in one direction. The spinning electrons between them behave the same. The other ones of the electrons are aligned tend to remain aligned with the external field that is removed. The electron alignment of the ferrite is called orbital motion of the electrons about the nucleus of the force of the whole of the atom together with the stack of the magnetic fields applied. The electrons try to align with the spins active with the new force of the attempt of the electrons balance between the interaction of the new force of the binding of the force cover the electron of the womb on their axis, shown in figure 174. Womb of the electrons have the natural resonant womb frequency and variously shrink with the implied field. Ferrite actions based on this behavior, electrons under the influence of the external field, resulting womb frequency. Spin axis, womb, and steady magnetic field of the spinning electron. Alright, ferrite actuator can be constructed to actuate the particular microwave frequency allow others to be passed unaffected. This can be done by placing a ferrite center in the center of the waveguide, as shown in figure 172. The ferrite must be positioned so that the magnetic field cover the electron and perpendicular with the energy of the waveguide is steady with the external field cover the electron of the womb to the same frequency with its energy to be actuated. Since the womb of the frequency wobble of the frequency is sampled of the energy frequency for the energy of the waveguide, also add the wobble of the electron. The spin axis of the electron change with the direction of the double of the wobble motion of the energy. U of the forcing of the action increase the wobble of the energy of the waveguide. Thus, the energy of the waveguide is saturated with the ferrite of the given off the heat. Energy of the waveguide, a different frequency of the womb wobble. The frequency of the ferrite is largely unaffected because it does not increase the amount of the electron wobble. The resonant frequency of the electron wobble can be varied over the unlimited range of the change of the strength of the electron magnetic field. Alright, ferrite isolators. Isolator of the ferrite device can be constructed so that they allow the microwave energy to pass one direction, block for the energy of the other direction waveguide. But this isolator constructed with a piece of placing a piece of the ferrite off center with the waveguide shown in Figure 175A. Magnetic field supplied with the magnet adjusted to make the electron wobble. The frequency of the ferrite equal to the frequency of the energy traveling down with the waveguide. Energy traveling down the waveguide from the left to the right with the set of the rotating magnetic field. The rotate of the ferrite material in the same direction of the natural wobble of the electrons. The aiding magnetic field increases the wobble of the ferrite electron so that much of almost all the energy of the waveguide is absorbed, dissipated as heat. The magnetic field caused by the energy traveling through the right or the left of the rotate of the opposite direction through the ferrite, having very little effect with the amount of the electron wobble. In this case, the field attempts to push the electron in the direction opposite of the natural wobble with no larger movement that occurs since there is no overall energy exchange that takes place with the energy travel from the right left is expected to be very little. Permanent magnet ferrite, the magnetic field of the waveguide. Alright, your ferrite phase shift of the wave. When the microwave energy is passed through the piece of the ferrite, the magnetic field and another effect occur. The frequency of the microwave energy becomes much greater than the electron wobble frequency. The plane of the polarization of the wavefront is rotated. This is known as Faraday rotation effect. The illustrated Figure 176 with the ferrite rod is placed along the axis of the waveguide with the magnetic field set along the axis by a coil. The wavefront enters the section of the containing the ferrite set up with the limited motion of the electron. The magnetic field is over the wavefront. While the wobbling electrons interact with the polarization of the wavefront is rotated with the amount of the rotation depends on the length of the ferrite rod. The direction of the rotation depends upon the direction of the external magnetic field can be reversed. By reversing the field, the direction of the will remain constant no matter what the direction of the energy of the waveguide travels as long as the external field is not changed. So for the waveguide ferrite with the polarization entering the wave the DC magnetic field with the polarization of the leaving wave. Polarization of the leaving wave, polarization entering wave. Chapter 1 summary. We're going to cut the tape. I guess it was about 10 minutes, 6 minutes.